There are a few geometry facts that we need to be familiar with before we attempt to do any geometry word problems. So let's take a look at some of the common facts that are needed for these type of problems. First of all, in a triangle. Obviously, triangle means you have three sides. That also means you have three angles. Now, if we were to call these angles A, B, and C, then one thing we know about every triangle is that A plus B plus C is going to equal to 180 degrees. So in other words, in any triangle, no matter what type it is, your three angles always add to be 180. Now in the word problems that we're doing here at the beginning, we need to use only one variable. If you introduce more than one variable into the problem, you will not be able to solve it. So let's say you were given a triangle problem and you're asked to find the three angles within some triangle. And you were told, for example, that the first angle is twice the smallest. So if we wanted to make this top angle represent our smallest angle, then being told that one of the other angles is twice that means we can represent it with a 2x. And then if you're told, for example, that the last angle is 3 times the smallest, we could represent it with a 3x. Now that all three angles have been represented and only one variable has been used, we can simply add them up, set it equal to the 180 degrees that we know all the angles have to add up to be. We would find that 6x equals 180. Dividing by 6 would give me x equal 30. And of course twice that would give us 60 for the other angle. And then 3 times that would give us 90 for the last angle. So just knowing that these three angles have to add up to be 180 allows us to solve this problem. Another thing we know is that complementary angles add to be 90 degrees. That basically means that when two angles form a right angle, then, again, if we name those, say A and B this time, A plus B is always going to be 90 degrees when we talk about complementary. And for supplementary, our two angles are simply going to add up to be 180. Don't let the A, B, C, and the A, B, and these other examples fool you into thinking that you can use two variables. Once again, you can't use two variables with this type of problem. You have to use only one variable at a time. For example, if they said you have two angles and they are complementary, well, first thing we know is something's going to be added and set equal to 90 degrees. Well, now we need to be told more about these angles so that I don't have to use two variables. Well, if they were go on to say one of the angles is 14 degrees less than the other one, then you could represent one with A and you could represent the other one with A minus 14. We could combine our two like terms, add the 14 to both sides, coming off here to the side to work, dividing by 2 would give us one of the angles, and then subtracting 14 from that would give us the other angle. So we would have our two angles, because they did give us an example of how to use the variable to represent the two angles. Now the next thing we want to look at is going to be vertical angles. Now vertical angles are formed whenever two straight lines cross each other. Now we actually see 1, 2, 3, 4 angles being formed here. But the vertical angles are the ones that are straight across from one another. So if this top angle was a 2x plus 50, for example, and the very bottom one was a 4x plus 12, I could say that 4x plus 12 was equal to 2x plus 50. I could subtract 12 from both sides to move over the constant. Subtract off the 2x, and I'd have 2x equaling 38. So I would find x to be 19. And to find the actual value of these angles, I would have to substitute the 19 back in for one of the x's. So substituting it back in, I've got 2 times 19 plus 50, which is 38, plus 50, which is 88. So these two equal angles measure 88 each. So those are some examples of the geometry problems you're going to face. Angles in a triangle, complementary angles, supplementary angles, and vertical angles. And one last reminder is that a rectangle, or for that matter, a parallelogram, in both of those figures, the angles, all four of them, are going to add up to be 360 degrees. So if you're given variable representations for each angle, you simply have to add those four angles, set it equal to 360, and you should be able to solve your equation based on that.